Cool. So we are on the second session for this Road to Wiki program, cohort 2. I welcome you all to the second session where we will be talking about CI/CD pipeline. We also have an expert here about who will be talking about CI/CD pipeline and more about some industry based session. I hope you are all ready for that. I know it's cold outside, but we are doing the session, and today we have Prateek with us. He's a distribution engineer at GitLab. So, if before Prateek takes in, let me clear about GitLab. So, you might be familiar about GitLab, but some of you think that GitLab is only used as a warehouse where you put and store your code so that it doesn't you doesn't lose it. But in the professional world, because of CI/CD pipeline that GitLab popularized, the moment developer saves code, GitLab reboots, wakes up, test it, secure it, and ship it. So that's the power of GitLab. We have Prateek, a distribution engineer from GitLab. Before joining GitLab, Prateek was a senior software engineer at Nasdaq. He's expert in infrastructure that power code delivery, especially in CI/CD pipeline. So if you have any doubt related to this, feel free to ask to Prateek. Over to you, Prateek. I hope your mic is good to go and it's audible.
Ankit, you can let me know if my mic is audible.
Yeah,
Maybe,
absolutely.
yeah, it's audible. Perfect, perfect. Let me just share my screen. Let me present my screen and then we can get started, I think. Okay, hello. Yeah. Let me know if my screen is visible. Ankit?
Yeah, it's visible. Thank you.
Okay, so let's get started. Okay, hello everyone. Good evening. It's so lovely to see that on a Saturday, that is the second Saturday of this new year, everyone has joined in, around 100 folks that I can see, and you guys are here to learn. It's such an honor. Thank you, Ankit, for inviting me. And lovely to see that so many people are getting interested into this topic. So, without any ado, let's get started. Today we'll be talking about the basics of CI/CD. And short, CI/CD has always been mentioned. This sometimes people say it as continuous integration and continuous deployment. Sometimes it is called continuous delivery. It's just synonymous. Does not matter much. Before we get started, a little bit about myself. So, thank you for the introduction, Ankit. But just for a formal few seconds, I will let you know. I'm Prateek Singh. I work as a distribution engineer at GitLab. If you guys want to connect to me, you can scan this QR code on your screen and you'll be able to find all of my socials. I'm pretty much active on LinkedIn or Twitter. Uh, Other places I'm not that active. Coming to what I do at GitLab is the name distribution engineer is a little bit confusing. I can understand that. But what basically my work is to deliver different packages that help you install GitLab on any system around the globe. So multiple Linux distros, whatever Kubernetes cluster or wherever on whichever format you want to install and run GitLab, my team comes in and delivers that. Right. Coming to my past experiences, yes, I have worked at Nasdaq, I have worked at HackerRank, Mercari, GitHub even at one point, and JustPay and a few other internships. But enough about me. I hope that if you want to catch up, you can scan the QR code or you can just find Prateek Singh. You might find the same particular photo. This is my official logo at this point, what Ankit was also joking about. So this has become my logo for the last 4 or 5 years now. Let's get started today. So, what is CI/CD? A lot of people have always asked me that, as a beginner or a fresher, it's always confusing that, hey, we know how to write code, hey, we know how to take an input from a compiler and make the, make the function run and then give the output. But we are not sure what CI/CD does. Now, let's forget the software world for a small time right now. Let's get into automobiles. So, if you have seen any automobile industry ever, or even if you have seen a National Geography documentary about the Ford factory or anything, you might have seen that in every company or in any automobile company, there is a worker line, right? Every engineer works on their specific part, and there is a continuous pipe that moves going on. At every stage, an engineer comes in attaches their parts of the car and process, and at the end of the line, a finished product comes out. You can think CI/CD pipelines in the same perspective. A CI/CD pipeline ensures that whatever several other engineers are working on, all of it comes together and builds a perfect product at the end of it. Similar to what I was making an example with the automobile industry. As in the automobile industry, the work line makes sure that every part is handled by a specific engineer. Same way, a CI/CD pipeline ensures that every part is handled by the right engineer. They make their part, and then the pipeline or the further engineers down the pipeline take care that okay, whether it is compatible or not, whether it is done right or not, the testing can be done. In short, if I have to say, just imagine, as of now, I can tell you about GitLab. We are more than 2,000 people in the company, and you can just imagine there are 2,000 people spread across the globe. I have my teammates working from Japan, some people are working from Europe, some people are working out of America. So we are spread across the timelines. So don't only think that CI/CD pipeline is one thing that is helping you deliver software. It is also helping the entire team collaborate. So even if a engineer who's working out of Japan at what time is very late for him, that's the morning for an American fellow. And they still can collaborate just because they can just see that okay, what has been done, does the CI/CD pipeline tells the output of it or not? It's not necessarily always about code, it's also about communication, right? Coming to the specificalities of CI/CD. So, as you can understand, CI/CD is two parts of it. First is called the continuous integration and continuous deployment. Let me take to you a little story wise, and then it would be much better for you to understand. So, suppose today you are going to contribute, and I'll show you with an example after this as well. So, suppose you today go on to contribute to some open source community or some open source project. Over there, what will you do? You'll first make an issue, you'll make the changes, you'll make sure that the feature works. But what happens when you push the code? What happens when you submit the work that you have done? So these are some generic phases of a CI pipeline or a CI phase that would happen, and we'll learn about that today. So before anything that happens in most, again, this is not the what to say, a very strict rule that every companies or every project follows. This is much of a generic overview that I'm trying to make all of you understand. It can look very different for other companies, but in general, let's understand what happens. The very first phase at any company or any open source project is a linting or a formatting job. So as soon as you submit your work, the first thing that happens is it makes sure that hey, is the code perfectly oriented or not? Is the alignment correct or not? Is if so, certain companies certain different parameters to make sure of this. As you can understand at this point, it's not exactly what it does, but just making an uh, small example over here. So you can understand some people refer spaces, some people prefer tabs, some people refer snake casing, some people prefer camel casing. So this particular job, the first step is just to make sure that the code that you have written, we are not sure whether it will work or not, but we are just making sure that it is checking for the all the orientations are coming correctly or not. Coming to the next job are pre-checks. So pre-checks look very different for every project and every company. Basically, these will be the tests that will make sure that the changes that you're trying to do does not harm the project during compilation in any aspect. What do I mean by that? So some hacker or someone can do this, right? That they can purposefully send some wrong data into their Git commit and push it so that when the runner picks up the code and runs it, it just executes that command, and no one wants that. So to make sure of that, pre-checks are done. Pre-checks are also done for versionings. So if suppose you're using some dependencies and suppose you're using an npm package that is on version 3, but the project is on version 4, although the code might compile, but moving down the line, you will see that it will be, dependency versioning issues. So these kinds of pre-checks are done over here. People make sure that the dependencies that you're using have all the things correctly in the same order with the project or the team or not. Now comes the important part, that is compiling. I think again, as you can understand, in the world of IT, there are different kind of languages, compiled languages, non-compiled languages. So this could be a different thing, but basically compiling is what you guys already know as of now. Once you run the code, it compiles, it makes sure that the compiler is understanding it. You have not done some very hilarious mistakes such as dividing by zero or something like that. It goes through the every check that the compiler has. Now, once you have your code compiles, now your code has compiled, it will actually start the building phase. So building phase is basically making a package out of it. So how do I explain package to you? So if you guys have ever used a Windows machine or a Mac machine, you must install a software that is in the format of .exe, right? Or in Mac users might have seen .dmg packages, right? So these are packages which are in a very, again, not the exact right word, but you can understand binary or executables, which it is called. So once these executables are built, then you can actually install it some machine and see that, hey, whether what you wanted to build is actually working or not. So what I'm trying to say is that you can have a code written which is logically correct. 2 plus 2 can be equal to 4. But the question was never about 2 plus 2. You have written a right code, but that is not what it wanted to do. Then how do you check it? You can't just compile and check it. You have to build the executable, run it somewhere, and then see that, hey, whether it is working or not. So this is the part of the building process where we build the executables, the binaries, which can be installed on some system and test it out. As very clear as that, the next stage come to tests. So once your building has been done of the code that you have written, people are sure that the things are compiling are building. Then there is a suite and a plethora of test cases that developers come up with. They want to make sure that if you're working on a feature A, it does not impact feature B. If I have to be very particular, if suppose you guys use WhatsApp on a daily basis, so if a developer is working on the feature that helps to record your voice notes, there is another developer who is concerned that maybe this voice note feature should not impact the feature that helps you to call on WhatsApps. Basically, both of them trigger the mics and the speakers, but these are very different features. How do you test it? So this is where the plethora of tests comes in. Once you have the executable, once the binary is ready, it is installed on a system, then it is tested. It is very aggressively tested that, hey, what you wanted to build is working or not. Now that we have seen that is the code is in a perfect condition, whether the pre-checks are done, it is compiling, it is building, it has tested all the things, then we save artifacts. So basically, it's very simple to what we do on a daily basis. So suppose we have Google Photos or Google Drive, you save your photos, your videos, your memories over there. Similarly, once companies make sure or the project makes sure that, hey, yes, the thing is working actually, you want to save it. You don't want to save a bad picture, right? So you want to only save the good picture, the good memories. Same ways you want to save the right artifacts. That's why it's at the end of the slide. I'm going to give you guys a couple of minutes. Ankit, can you help me with the chat? If there is some question, basically on CI, I would like to take it up now, and then we'll move to CD.
Sure, sure. I guys, if you have any questions, can you put it in the chat box regarding to related to CI?
I'm just waiting for this because I know that it is a little bit a lot to take in one go. If you have never worked on a open source project, it feels like, oh my God, why is this guy coming in and teaching us 10 different things? But yeah, I can understand it can be a little bit overwhelming. So if you have any questions, put it down. Else we'll start with CD.
Guys, if you have any questions, I think the chats are open. Guys, if you have any questions, feel free to put it in the chat box. Yeah, you're able to put it in the chat box. Yeah. No, we didn't got any question as of now, Prateek. I believe
Okay,
for the next step.
perfect. So let's move on to the next phase. So
Yeah,
now that
Prateek, we
sorry,
got two questions. Sorry. Can you
yeah.
explain one more time about saving artifact?
Okay, so suppose when you go on a trip, right, you take 1,000 pictures. Some of the pictures are blurry, some of the pictures are very perfect, some are photo perfect. Do you post everything that you get on on a trip? Do you post everything onto Instagram? No, right? You only put the perfect pictures. You make more filters, more everything, and then you post it on Instagram. Similarly, when we write code, we don't want to save every software that we build, every component and patches of software. We only want to save the ones which builds, which compiles, which passes all the tests, and then we save the artifact. In very simpler language, it will look something like WhatsApp 2.0.exe. So if there are some Windows user, you know what an exe file is, because whenever you install a software, it is called an exe file. Or a Mac user might know about a .dmg package. So it's any software is with the extension of .dmg. So saving artifacts in this aspect is this. In actuality, it is Docker images, and in actuality, it can be some different kind of artifacts that the company prefers. But yeah, that is about saving artifacts. I hope that makes sense.
Yeah, thanks. Next question is, can you say that CI/CD is a type of SDLC?
Yeah, yeah, exactly. See, so CI/CD is the spine of a SDLC process, if you see about it. So I'll explain in a very simpler manner. So you see the human body, right? Don't take it very literally, but you could just take it as an example. So in a SDLC process basically means the software developer lifecycle. So it is from an idea till the product. So in this entire process, you see the idea, the brainstorming, taking upon a feature, what has to be built, that comes up from your brain, right? That is the top of your head. And then the rest of your body cannot stand without a spine. So that is your CI/CD pipeline, and your whole body is the SDLC process. So that's why I started by saying that CI/CD pipeline is the spine of the whole SDLC process. If there is an idea that has to be taken into full form humanoid body, it cannot work without a spine. Same, the SDLC life cycle cannot perform without a CI/CD pipeline. Right? Make sense?
Yeah, thanks. I
Mm,
think
yeah.
Pushpet is asking what problem does CI actually solve?
Okay, so CI solves as a problem. I think I missed it, but I was mentioning this example. So there are two kinds of engineers, say, working for WhatsApp. One is an engineer who is working on delivering voice notes, a feature which is related to voice notes. And there is another engineer who works on WhatsApp calls. Now, if you think about it, both of the engineers are using your phone's mics and cameras. Both of the engineers' code basically is using your phone's mics and cameras, mics, cameras, speakers. But you don't want that a voice note feature should impact anything related to a WhatsApp call. So the continuous integration process ensures this, that if there is a feature that is related to voice notes, it should not affect anything on the WhatsApp call. The WhatsApp call should work as it was, or whatever the engineer of WhatsApp call wants. This feature should not come up and have any problems with each other. I think that makes a little bit of sense.
Yeah, yeah.
Yeah, fine.
Neha is asking, when
Mhm.
I push our code in repos, then what is the role of CI after this?
Okay, that's a very good question. Let's hold off to it, because after this I'll be showing an example and you'll see very perfectly how does it looks. That's why I had kept some time to show a real world example. Let's get started a bit with the CD part, and then I'll switch to the example to show you exactly what it means. So, uh, coming to the continuous deployment part, so don't all anyways think that CI/CD are two different things. CI/CD is the same thing. The CD part means that continuously updates keeps on rolling in. Every software that is built, a company decides that whether the feature has to be released once a month or every day a new feature should come up, right? How does it work? Continuous deployment. Once the artifacts of the continuous CI end job that we saw. So once there are new artifacts in store, there are new versions of a software available. Then continuous deployment kicks in. It detects that yes, there are new artifacts that are there. It triggers a pipeline. It triggers a workflow. In very simple example, it pushes these new install onto, suppose, your Google Play or your Apple Store. And then once it is deployed, once it is out in the public, then continuous deployment is not exactly a part. Monitoring is a part of it, but monitoring, I'm just writing it because now it's the end step of CI/CD, that once It is integrated. Once it is deployed, DevOps engineers monitor it, see that whether it is working correctly or not. So continuous deployment is very simple. I don't think that there is much to tell about it. And thus, I'll be moving to the next slide. Let's take a real world example, right? Because there's nothing like the real world. Where is it? Okay, let's go. So suppose this is the repository that this is the company that I work for, and this is the repository I don't frequently work on, but yes, this is one of the repositories. So suppose let's very quickly get into it. That how do you start contributing to GitLab as an organization? So whenever you open a project, whenever you go to an open source project, you have to first find for a contributing.md file, as you can see. Every repository has this file. A good repository at least will have this file. It will tell you about how to contribute it to a particular project. You can see contribute to GitLab. There is another page. You'll find every detail that how you should contribute to GitLab and whatnot. The basics are that you go to issues, you find a good issue that you can work on. So you go to the repository, you find, so you can see there are a bundle of issues. You can find an issue that you want to work on. You can talk to the maintainer, you can get it signed, you can work on the code. And once everything is done, here where is the part of CI/CD kicks in. So once you have done everything, then you'll push your changes onto GitLab or whichever platform that you're using, and then it kicks off a pipeline. As I was mentioning earlier, that how a normal pipeline looks like. And this is something that is out in the open. It is not something that only I can log in and see. Every one of you can just go in and see. This is not my office ID. This is actually my personal account that I'm using right now. So each one of you can see this, that the pipelines which are there. How does it looks? So the cache part, let's leave this out right now. But see, from here, what I said, the pre-checks are being happening. You can see there are pre-flights, there are preparations happening. Then there is the linting part that I told you about, right? So there are linting checks that are happening. And then there are somewhere you will see there will be compilations. There are some pre-checks, pre-tests happening. And then there are post-tests happening. Then there are reviews. And then there are downstreams. So there are multiple more jobs that the company thinks that, yeah, these are necessary. So this is how a CI/CD pipeline looks about. That once you have done, it will tell you that okay, how does it works. Let me look into a good example. Let me just take a minute. Okay. So suppose this engineer has pushed something, and see there are so many tests as I was mentioned. There are 430 tests. So what I was mentioning earlier, there are multiple tests, and every code has to pass through all of these tests, and only then it can be said that yes, it is something that is correct. And you can see after so many things, only two jobs have failed out of 310 jobs. Only two jobs have failed, and this has not been merged. So this is how it looks like. It is a pre-test happens, then there is preparation, then there is the building part that I was mentioning, right? Then there is a linting part, then there are testing, there are post-its, then there are QA, then this is the CD part if you come to it. So the page is this part that you see. This is where it is going on to production. And then we have further pipelines for the enterprise versions that, okay, what are the tests that are related to enterprise that are needed. So this is how an actual CI/CD looks like. I know very honestly at the start of it, it looks a little bit, what to say, overwhelming that, oh my God, what is this? What is all of this? But usually a lot of, oh, shoot. Okay. So a lot of projects does not look like it if I go to something of my similar personal projects, right? So my personal projects does not look like this. My personal project pipelines are pretty simple and very basics. So if you see, it will have a couple of jobs. It will do container scan. It will do the deployment part. So this is the CD aspect of it. This is the testing aspect of it. So it looks, wait, this would be a good example to explain all of you. So this is the exact thing that I was mentioning. So first, it is a personal project of mine. So first, I'm doing linting. I'm making sure that it is the format is correct. Then I'm building the code. Then I'm testing the code. Then I'm making the artifacts. This is basically the step of saving artifacts, which someone was asking, and then I deploy it, right? So this is how an actual CI/CD pipeline looks like. Coming back to this, so any questions at this point, and then I will be off.
Any question, guys, on this? I think the chat is on the latency of 1 minute. I think they will put some questions. Yeah.
Okay, okay, sure, sure.
Somebody asked, so we can use CI/CD pipeline in our daily project.
Yeah, definitely. See, if you learn, it is kind of what I was saying. It's what to say, it's a habit. If you use it on your daily projects, your projects will eventually become very good. You will also, as I was mentioning, it is the spine of an SDLC process. If you're a software engineer, you can't say that, hey, I have no idea what a CI/CD pipeline is. I don't know how to run CI/CD pipelines. You can't say that. So that's why if you are doing it on a personal project, it's very good to do. And as you say, I was showing a personal project of mine. All of my personal projects have a CI/CD pipeline at this point.
Yeah. Dave is asking, do pre-check compares with already written test cases, and what is the difference between pre-check and the test?
Perfect. That's a very valid question, but let me come back to it. So, how does a pre-test, a pre-check, and a test differences is? So, pre-check will make sure that hey, are you using the right version of Python as the entire other team is? So, you might have written a code which is Python 3, but other companies, other people are using Python 3.4, or maybe you have used the dependency, or you have tried to install a dependency which is at version 2, while the other team or the other parts of the project is using a dependency of Python 3. Sorry, a dependency of some NPM pack that is at version 3. So this is a pre-check. This is not an actual test. This is a pre-check. We are making sure that, hey, are all the bases, all the prerequisite matching or not? And then test comes up is that, okay, you have written this feature, but is it interfering with other features or not? And is it making the existing feature in the same benchmarks or not? Coming to simplifying it a little bit. So a test would mean that you have done a change on, again, I come back to WhatsApp because it's a very common software that we use on a daily basis. Just suppose there is a engineer who has done a software change which helps you modify your voice on a voice note. You can sound as the Iron Man on a voice note. So this feature should not actually be interfering with a feature of WhatsApp calling, right? Because that would be unethical, or that would be another department that is not really related. So a pre-check is just for the dependency and versioning and just on the software. It is not on the end of how your feature comes out. The test is on the end of feature that, okay, what the feature does and does it affect the actual feature or the actual product or not. I hope that makes sense. Yeah, thank you.
Yeah. One question I have, Prateek, for you.
Yeah.
Tell them what are some tips and tricks they can use while contributing to any open source project. For example, what are the most common mistake? Like I know we were as GDS lead at the same time. So what were the
Mhm.
few mistakes that we used to do and how we can overcome from that?
Okay, so let me count in my head how many suggestions I want to give to you. Uh, okay, the very first feature, the very first thing that I will tell you as an open source contributor is a lot of people look into the repository of suppose GitLab right now. It's a very huge repository. You can be very afraid that, oh my God, how do I understand this entire piece of code? And I have no clue how to get started. And bhaiya, do you have to understand everything of it? Or don't. Take a step back, breathe. You pick an issue. You take up a simple issue. Suppose there is a simple issue that we want to update the emails of the people who have signed up before 2005. Example, just giving an example. So you go up, you check for this issue, you talk to the maintainer that, hey, I do know that maybe I can do this. I have done databases before, and you guys are using Postgres. I have done Postgres, so I think that it is something related to a Postgres query. I can help you out with this. You get the issue assigned, and then you don't read the entire repository. You take it one bit at a time. You'll start tracing back that where does the email part comes in, then from email part where does the email part comes to the database part, and then in the database piece of code you'll find, okay, here is the query that I want to change, or here is the part where I want to hit a new query, and then you contribute. A lot of people get overwhelmed and just stop contributing to open source. So that's one very good advice at the very start of the bat. Next advice I would definitely tell to you that have some patience on when you're doing open source, because people are spread across time. Everyone is doing their own job and their own things. So it can take some time for people to be answering you. Don't lose patience so early on. So it's fine. And lastly, and very importantly, please and please don't spam maintainers. Don't do something that you are not proud of, that is, you're just doing for the sake of it. It will not help anyone, not even you, not anyone else. If you have done actual contributions, it will just show up. If you're just making, saying that, hey, contribute me, hey, let me allow this, just in the sake of getting a t-shirt or something else, it does not matter, because that is not what open source is about. It is, at the end, it's about that whether did you contribute to a feature on the project. It's not about how many commits you made. It's not about how many issues you raised or how many issues you got assigned. At the end, it's whether the feature that you built is on the project or not, in production or not. So that would be my three pieces of advice I can.
Yeah, thanks, Prateek, for that. I think this will really help them as GSOC is coming.
Yeah.
They just completed their Hacktoberfest, so I think this will really help them. Well, we have got few good questions. Pushpit is asking, at what point in your pipeline do you say CI job is done and why?
Okay, so see, as I was mentioning, CI/CD is not a very exact bifurcation between the two. They are the same thing. It is just one pipeline. Other people can decide how it has to be. As I was showing you on the GitLab project, that there are downstream pipelines that does the deployment or something else. So it's not about, deciding that yes, this is where the end of CI happens or the start of CD happens. It's not like that. It's just theoretically saying that, okay, this is the part of integration, this is the part of deployment, but it always runs together. You can't say that I will only have CI and not have CD. It does not make sense. Or I will only have CD, I will not have CI. It will not make sense. So it's not an exact bifurcation. It's just a theoretical concept. But when it comes to implementation, it all looks in the same one pipeline.
Yeah, next question is, who owns CI/CD pipeline and how are changes to it reviewed?
Okay, so these CI/CD pipelines are always and always owned by the DevOps engineers, and the changes are reviewed by the DevOps engineers solely. We look into it that, okay, so suppose I'll tell you an example right now from my work. I'm looking at a change in the CI/CD pipelines because I think that the pipeline can run a bit faster. The pipeline is taking like 2 3 hours. I think I can shorten it to 40 minutes, and I'm working on it. I'm making changes to it. I see that the build process can be short circuited, and other things can be done. So this is owned by the DevOps engineers and it is reviewed by DevOps engineers only. Okay, Ankit, I'll take one last question and then I'll be off.
Yeah, I think the best question would be, yeah, how I can perform CI/CD in GitHub, or what it is need to use any other software like GitLab or another.
Okay, so although I work for GitLab, yet I will say this. If you're thinking as a DevOps engineer, these at the end of the day, everything is a tool. It does not matter whether you're doing on Jenkins, whether you're doing on GitHub, whether doing on GitLab, whether doing on Bitbucket. It does not matter. At the end of the day, you learn the concepts which I told you today, and you implement it. The formatting, the syntax looks different for everything. But then again, at the end, it's grills down the concept that, hey, did I lint it or not? Did I scan it or not? Did I tested it or not? Did I deploy it perfectly or not? So it does not matter which software you use. You can pick any one that you want to. I honestly started with GitHub at my point because I was doing an intern there, and then eventually I learned. I think I have learned Circle CI also, Jenkins also, Bitbucket also, and currently I'm working at GitLab. So really, it does not matter much. If you have to pick, I will always say start with GitLab because I find it the most easiest. But it's totally your call.
Yeah, I think
Yeah,
one last question we have from Anshdeep. That's actually good question. Does
sure.
automatic deployment from GitHub to render comes under CID pipeline?
GitHub too, sorry.
To render comes under CI/CD.
So it is, you can say that it is a part of the concept of CD, but it's not a CI/CD pipeline. At the back end, it is a webhook. So when you change some, you make a commit to GitHub or wherever your project is, it triggers a webhook to your platform that, hey, this new project has come up. So basically, the transaction of saving artifact to new artifact, which I was mentioning in the CI/CD slide. So once you make a new change, it just takes up from a webhook that, okay, this new change has come up, and then it goes ahead and deploys it. So that's how it works. It's not exactly a CI/CD pipeline, but it is a CD process,
Cool. I think
right?
that's all. Cool.
Okay. Okay. Thank you, guys. If you guys have any more question related to DevOps, related to CI/CD pipeline, feel free to reach out. I'm always available on LinkedIn, Twitter, whichever you prefer. And it was very good and very nice to